All right, we'll just get started. So thanks all for having me. A couple of preamble slides I will just ram straight through. All right. So hi everyone, great to meet you all. My name is Jeff Chow from Capital One, and today I'm going to talk about how Capital One balances lower cost and peak performance in Databricks. A little bit about me. So I actually joined recently from a startup called Sync Computing. We joined a couple months ago, and we specialize in Databricks cluster optimization. And so I'll get into some of that. And we're actually merging our technology and product into Capital One's Slingshot product. So I'm excited to show you all both some of what that product can do and also kind of the best practices of how does Capital One in general attack Databricks spend. So a little background about Capital One. So it's a technology-first company, and we changed from the inside out all the way back in 2016. Capital One went all into the cloud, which is a major kind of disruptive technology for kind of the banking industry as a whole. And then in 2022, we launched Slingshot, which is our first kind of B2B SaaS product aimed at optimizing Snowflake cost and user management. And in around 2024/2025, we launched Slingshot for Databricks, which you'll see a couple slides here on. And then we also just launched Databolt, which is another kind of B2B SaaS security product in data tokenization. So this is kind of the journey of Databricks and kind of why we're all talking today. But let's focus on Databricks. So what is the deal with Capital One and Databricks? So since 2017, we've grown our Databricks usage across the enterprise. Our usage is pretty much ridiculous. We have 500,000 queries run per year, 5 million job runs per year, over 4,000 users plus monthly, and this usage is only growing every month. So it's easy to say that our usage is pretty intense, and there's a huge question of how do you manage all of this? How do you reduce costs, but keeping employees happy, keeping jobs running, et cetera. So the goal of this talk is to provide kind of a high-level framework of the strategy of how do you actually attack such a sprawling problem. And we kind of broke it down into these 4 steps. And so the first step is just understanding your usage and your business goals. So step 1 is, well, what are you trying to achieve, right? So let's align on what does success look like for you, for your business unit, for your boss, for your boss's boss. For example, how much cost savings are you even trying to achieve? Is 10% gonna change the world for you, or are you looking for like 90% cost saving? Depending on what you're looking for, you're looking at very different solutions. So try to calibrate, what exactly are you looking for? Another question is how much engineering time are you willing to spend? The deeper you cut, the more resources you put into this, probably the better you'll be able to do. So these are some of the trade-offs you're gonna have to consider just from the get-go of what you're looking for. And then third, are you willing to trade off performance and reliability? Are you a shop where every single job in Databricks has to run and has to never fail, and actually costs aren't important and you just need stuff to run? Or are you running a bunch of ETL jobs that run in the middle of the night and it doesn't matter if they run a little bit slower or maybe they skip a run here and there? The more flexibility you have, the more you can do in terms of optimization, cost savings, experimentation, et cetera. So these are just kind of high-level framework questions. And to get a little more tactical, something that everyone should do is look at contract analysis. So obviously, for most people, you sign kind of an annual contract with Databricks. And the big question is, are you on track to meet your spend goals, or are you about to burst through 6 months early? So on the bottom here, you have kind of, obviously a simple binary choice. Either you're on track, and there's a big question of, do you even want to do anything anymore? If you're on track, you should probably just stand up, take off your headphones, and just walk out because you're A-okay and everything is sunshine and peaches. I am guessing most of you are probably on the right-hand side where you're looking at your spend and you're like, oh shoot, you're projecting in another 6-12 months down the road, we're gonna bust through our contract and I'm gonna get yelled at, right? That's kind of the right-hand side is what we're looking at here. So once you kind of align on really high-level business goals and understanding your goals and what are your trade-offs and what you're willing to go down, now let's get even more tactical and let's go find out, all right, what are our main cost drivers anyway? So typically, if you're a large enterprise, you might have many workspaces, many teams, might have a dev environment, a prod environment, you might have an ML team, an ETL team, probably a Gen AI team. It's probably all just scattered and it's really messy. And typically it's broken down into workspaces. And so a good kind of first sanity check is to see, all right, which workspace is driving most of my costs over time? And so here you can see kind of a bar chart of costs versus time, and it's broken down by the various workspaces. So you always want to try to find kind of your main bottlenecks. So let's go and tackle kind of the big spenders. Which group is it? Is it data science? Is it the data engineers? Or who's the biggest offender? And then once you kind of target, all right, which workspace or which group of people am I going to go after? Then you can start to ask, all right, which compute SKU is the largest? And what is the breakdown? And typically in most companies, it's one of three. It's either jobs compute, all-purpose compute, or SQL warehouses. Probably the Gen AI model serving stuff is creeping up, but for most folks, that's still kind of an exploratory space. So it's probably one of these three. And maybe it's like a 40%, 30, 30, if my math is correct, kind of breakdown. But try to figure out what is the biggest offender for you. Is it jobs? Is it SQL? Is it evenly distributed? Is one very heavy? And just to kind of understand what is the difference between these big three. Jobs compute are scheduled jobs. They're typically ETL jobs that are set on a schedule every hour, every day. They're typically orchestrated via workflows or Airflow or maybe even dbt. Interactive all-purpose compute clusters, these are typically used for research, like data scientists. You might have like a group of 100 or 1,000 data scientists scattered across the world playing with the latest ML, LLM models. And they're not really doing anything in production. They're just researching and playing around and trying to figure out new use cases. The middle column here is very user-centric. It's very fragmented. It's a bunch of random people doing a bunch of stuff, and it's really hard to kind of wrangle the costs there. And the third one is SQL warehouses. Obviously, it's all about SQL. These could also be kind of analytical workloads. You might have business analysts hitting your warehouses. It might be also random and ad hoc, or they could be scheduled jobs. Maybe DBTs orchestrating jobs and you're running on a schedule. So SQL warehouses can be both maybe ad hoc and at a regular schedule. So what did we find at Capital One? So we did this exact analysis, and it was pretty clear what we saw. Here's a kind of a high-level breakdown of the spend versus time, and the big blue was actually interactive APC clusters. So that middle column that I said, which is a bunch of like literally 4,000 people, were just spinning up all-purpose compute clusters, doing random ML ad hoc research, just spinning up clusters, and that was our number one cost driver. So obviously, let's go after that and zoom in and see what we can do there. And I've worked with many companies of all sizes, from mid-size to large enterprises. And I have this kind of rule. It's like a 80-20 rule. Like typically 80% of your spend comes from 20% of your workloads. And typically, typical best practices are, well, let's start with like top 10 jobs, or find your top 10 users or your top 10 queries. Like, choose what makes sense for you. In our case, since it was APC, which is a bunch of employees running jobs or doing kind of experimental ML, it was actually finding the top 10 users. And when we kind of zoomed into their usage and we looked at the cluster utilization, this kind of jumped out and scared us a bit. You can see on the x-axis is actually CPU utilization for your all-purpose compute cluster, and the y-axis is percentage of cluster. And that huge spike on the very left-hand side is basically saying most of our clusters are actually 0 to 10% utilized. That's kind of scary. That means we have these clusters, we're paying Databricks and AWS, and literally nothing is happening. And so that's hard to get any ROI, right? It's an ROI of 0. And unfortunately, it was a dominant case. And so for us, this was a very kind of clear-cut, easy way, kind of low-hanging fruit to go after these users. And we have to go basically send them alerts. We had to go talk to them, figure out what are they trying to do, trying to figure out. It was more of a human problem. It wasn't some like fancy cluster thing. It was just really just talking to humans, and governance was kind of one of the bigger cost drivers. So once you kind of figure out, okay, we figured out who or what it is, we understand technically what's going on. Now let's come up with an attack strategy. And there are kind of at a high level, there are two big paths you can take for attacking this. On the left-hand side, you have manual, and on the right, you have automation. So for manual, what we're talking about here are like best practices, some rule-based thing. You can do code inspection, but it's typically like, a top-down reactive system. We're like, hey, our spend is crazy this month. Engineers 1 through 3, go look at what's going on. Go do something. And then you have the right-hand side, which is automation. You'll probably need some sort of machine learning powered solution, something that can respond dynamically to whatever changes there are on your workloads. We'll probably have to utilize historical data. Obviously, the solution on the right is much more technically challenging to implement. But if you're at scale, you just can't manually tune thousands of jobs or thousands of queries by hand, right? You need automation. So these are like the two big forking paths. So let's start with the left, which is manual. And I think everyone should start here. This is like where you'll get a lot of bang for your buck. So you should tackle kind of low-hanging fruit things. Again, focusing on these top 3 offenders. Jobs compute, you can look for clusters that are underutilized, find jobs with high failure rates. Optimizing your code is very obvious. And we're going to zoom in a little bit deeper after this slide. And then what's new lately is serverless. So you have job serverless, APC serverless. And so you should try those out to see if those are worth it financially for you or if it works for your business goals. Interactive APC, it's similar, kind of manually go in, find your top 10 lowest utilized clusters, talk to your users. A big one for APC is that second bullet, which is migrate scheduled jobs from APC to jobs compute. For those of you who may not know, APC compute is about a factor of 2 more expensive than jobs compute. And if you're just running scheduled jobs, there's absolutely no reason why you should be doing that. So you should just move it over to jobs compute, and out of the box, you get 50% cost savings, which is pretty amazing. And then SQL warehouses on the right, you want to find warehouses with long queues, or maybe typically the solution for SQL warehouses is just downsize everything. If you just went in and just reduced everything by 1 warehouse size, you'd probably save, 20, 30% of your budget right there. There's also stuff like enabling auto termination to make sure you don't have idle warehouses just running. And then, of course, optimize your code is everywhere. So of all of these things, let me just quickly zoom into 2 of them. One is serverless, since it's so new. So serverless is great, and I'll just pick on one. For example, job serverless is great. There are 3 new versions. So there's performance serverless. This is going to give you the best runtime, the lowest start time. It's going to start pretty much instantly. Unfortunately, it's probably the most expensive. This is like a Ferrari. And if your ETL jobs need a Ferrari, then that's great. You should be using performance. They recently, about a month or 2 ago, released standard serverless. By the way, serverless means you don't have to pick instances anymore. You just click run and it'll go, and Databricks will actually run the compute for you. So all the selecting of is it an M5 or a R6G, all that stuff is gone. You just click run and it'll go. So that's what I mean by serverless. So standard is the same experience, no instance selection, no infrastructure, nothing. The trade-off there is it'll be about 40% slower than performance. There is a 5-minute startup time, so you have to wait for the cluster to spin up. But it potentially can be up to 70% cheaper relative to performance, so it can be much cheaper. And this is great if you have a job that's running like an ETL job that's running at 3 o'clock in the morning. Do you care that there's a 5-minute startup time? Probably not. You're asleep, and who cares that it's running 5 minutes later or that it's 40 minutes slower, right? So you have to really understand your use case and which one makes sense for you. And then there's classic, which is kind of the traditional cluster. This runs inside your VPC. If security is a big thing for you, you might be forced to use classic and you're not even able to use serverless because your company doesn't let you use serverless. But classic is nice because you can tune everything. So you can choose the instances, choose the cluster size. And if you're trying to hit a certain runtime, you can change it all. And you can really customize it. And you could potentially be even cheaper than standard. But it comes with the tax. If you have to manage it. You have to figure out what you want. So it ultimately depends on what you're trying to achieve for your business, on what cluster. And this is just jobs. I'm not even talking about APC or SQL warehouses, which also have their own serverless options. So you can see Databricks gets quite convoluted as you kind of peel back the layers. The other big one is obviously optimize your code. This one's hard to automate. This one is you're just going to need your engineers to go and look at their code. And optimizations are very bespoke, very custom. You have to implement what's right for you. Here's just a list of some of the more popular ones. Optimize and Z-order, partitioning, salting, column pruning, you name it. You can do a bunch of stuff to optimize both your tables and your code. And I highly recommend, if this is something you want to look into, Databricks published an excellent kind of summary of the best practices. Here's a link to it. That's the title. If you just Google Databricks optimization is probably the number one link. But you can, if you click on that, they actually have a great little cheat sheet of all of these and more to help you kind of figure out what's going on here. But this is hard to automate. You're going to have your engineers go in and look and think about and try it and experiment. But if there's potentially a lot of cost savings and runtime savings if you kind of implement this. At scale, how do you actually solve this? So everything I mentioned before is great for manual, top 10 jobs or once a month, go point in engineer, go look at it. But what happens if you have 1,000 or 10,000 or 100,000 jobs running daily? Forget manual, you can't do it. This is where you need some sort of automation. So for jobs compute, ideally you have a solution that can automatically tune your classic clusters, automatically A/B test serverless to see which one is right. Interactive APC, you want something that can auto-terminate clusters if they're low utilization, or auto-migrate jobs from APC to jobs clusters, or SQL warehouses, auto-right sizing warehouses based on scheduling. If you have this kind of repeat usage pattern, you want to auto-resize based on your usage pattern. Or you can, if you're really fancy, you can auto-route queries, do query routing so that they can go to their right warehouses. All of these are would be great, but they're they're not, you have to build them basically, or you can use a third-party tool, which conveniently is something that we do here at Slingshot. And so one of the things that we do is offer a machine learning powered jobs optimization at scale. And so here's just a quick snapshot. This alone could be a 20-minute talk. But basically on the y-axis you have cost, on the x-axis you have one of your runs. And essentially what you have here is you see the ML algorithm is actually going to experiment and toggle a few different cluster settings, and it's going to train our ML model. And around 5 to 10 runs, it'll figure out what to do, and then it'll automatically start reducing your costs. And this is all automatic. So while your engineers are out grabbing lunch, this thing is optimizing all of your jobs. And this is just one of 1,000. So this is how you want to optimize everything at scale, because no engineer wants to sit and tune clusters. It's the most boring thing in the world for an engineer to do. No engineer enjoys tuning number of workers and instance sizes and stuff like that. So let them focus on the interesting stuff and optimize at scale. One other note here is we actually also monitor the runtime. So as the solution is optimizing and changing your cluster, we're going to obey your SLAs. If you say, hey, don't surpass 1 hour, we will make sure that we adhere to that as we kind of tune the cluster and get you the best cost savings. But again, the big advantage here is automation. This all happens automatically, and you don't have to do anything. So on the last part is implement and monitor. This one sounds very obvious, but it's actually extremely convoluted if you actually try to do it in practice. So it's very obvious to monitor costs before and after, right? I just described a whole bunch of stuff you should do and try. Makes sense, go do it. You might think, all right, I'm gonna do it, and then tomorrow I'm gonna measure the cost, and then easy peasy, I know how much I saved. Unfortunately, it's never that simple. I've been doing this for a number of years now. It's never, sometimes it can be very simple if the code doesn't change, if data doesn't change. But unfortunately, an apples to apples comparison is actually really complicated because so many things can change. Data size can change, code can change, query volumes can change, new versions of Databricks can come out. If you're looking at it, in aggregate, new workloads can be added, old workloads can be removed. So understanding if a single change you made actually resulted in like a 30% cost reduction is really hard. Maybe you'll do something and your data size tripled, and you might be angry that like, hey, this didn't do anything. But you have to peel back the onion and be like, oh, actually my table tripled in size, and that's why everything went up. And actually the optimization I did work, but something else came in and clobbered my cost savings. And it's very convoluted. And so this is probably one of the hardest steps. And this is something that's our product Slingshot helps simplify and helps you understand. We can kind of aggregate all the things that could potentially impact it and try to give you like a value report. Because deciphering this, I'm going to tell you, I spent many, many hours with many, many companies trying to figure out, did it work or did it not work? And then at scale, what was the overall ROI? It's a really hard problem to solve. This is the last slide. And so finally, this is not a one-time thing. Unfortunately, you have to repeat this over and over and over again, right? The drill down I just did was just APC and users, but you should do it again. And then, a week from now or a month from now, things will change, workloads will change, and you're going to have to redo this over and over again. So our product, Capital One Slingshot, will help make this process a lot easier for folks. So thanks so much. We have a booth right over there. If this looks interesting, please stop by. I'll be there. Happy to show you a demo. But thanks so much. Appreciate your time. Thank you.